So let's talk about bar models. A bar model is something you can use to solve a math problem. It helps you organize the information you have visually so you can see what you have and what's missing and maybe some things you could try. In math, we use models of all kinds. When you think of the word model, you might be thinking of like someone who's just ridiculously good looking for a living, like your teacher. But a model is also just a small version of something, like a model airplane or a model of the solar system. A model is just something we make that represents something else. And in math, we do that all the time. So the essence of the bar model method is using spatial equality, which you can see not coincidentally in an equal sign. The top bar is the same as the bottom bar. They take up the same amount of space. They have spatial equality. In a bar model, we're going to use, the things that we know, the parts of things, to compare or calculate the total or the missing amount in the other bar. Having that right in front of you lets you see exactly what you have or don't have, and it makes it pretty intuitive to figure out what you're supposed to do. If only everyone did that, use what you know to solve problems. Don't just make stuff up like that one weird kid on the playground. Math, maybe more than any other subject, requires us to be abstract thinkers at a very early age, whether we're ready for it or not. And, some ways of dealing with that are to use lots of hands-on manipulatives. And if you don't have that, hey, grab a bar model. So in this example, if we know that top bar represents a total of 10, then the bottom bar, which is spatially equal, again, spatial is the space it takes up, then the bottom bar is also equal to 10 units, and we can divide the bar into equal parts and label them from 1 to 10. You can also represent that equality with other things like tally marks. You can put 10 dots in there. Or you can do it more abstractly with the numbers, whatever best suits your skill level. If you have the total value of a bar, which in this case is 10, and then you have a part or a piece, in this case it's 3, then we're going to use the equalities of the bars. They should both be equal. They should both be 10. We're going to use that to find the difference or the missing part, and you can use whatever strategy you're best at. You can count up, you can subtract. The missing part here is 7. 7 and 3 together make 10. And the bar model, what's great about it is it adapts with your skill level. As your number sense grows and you know how to break apart and put together numbers without drawing things, you'll begin to instantly recognize the missing parts. If you have a total of 10 and you have 5, then you know that other piece has got to be 5. Or if you have 6, it's going to be 4. Or if you have 7, you're going to need 3. Or if it's 8, you're going to need 2. And if it's 9, you're going to need 1. The bar model strategy is also called part-whole. And in most problems, you'll be looking for the whole or total or the largest or final amount and assigning that label and value, if you have it, to the top bar. And then below you would put the parts that are going to make up that whole or total and largest and final amount. If you have all the parts, like here you have 12 and 6, then you are going to put them together to find the whole. 12 plus 6 is going to give you the total, which is 18. There may be other problems where you know what the total, the final amount is. Let's say you have 120, and then you know one of the parts is 80. We're going to use what we have. We're going to take away 80 from the total 120 to find the missing part. The difference is 40. And that 80 and 40 together equal 120, which is the whole. And then in some of the problems, you'll be dealing with equal groups, but it's just as easy. Here I've got 6 groups of 8. I don't have the total, so I'm going to be putting all those groups together. 6 times 8 gives me a total of 48. Sometimes you'll be dividing also. We'll get into that later. But that's basically it. Hey, the best way to learn the bar model strategy is just practice. Mess up. Figure out what to do next time, build some background knowledge, get some experience. Before you know it, you'll be a bar model master, and everyone will love you. Maybe. I don't know. I can't guarantee all that. But you'll know how to solve a problem or two, and that's the kind of person we should all hope to be. Look, math can get complicated, like a lot of problems in life, like my problems in life. There's not always one specific method that's going to work for everything. But if you stick with the general problem-solving approach of understanding plans, solve, and check, the BAR method is a great way to start. After thinking about the who and the what in a problem and visualize what's happening in my head, I always ask myself, do I have the total? Do I know the final amount? Because that'll be my top bar. And then I go to, okay, do I need equal groups? This is going to help me know what to draw, what operation I might have to work on. Then I'm going to organize the information and label everything. That helps me know what numbers go where. When you label everything and see how the different quantities you have fit together, it's so much easier to spot mistakes and know if you're doing the right thing. So let's put that all together in a typical one-step problem. You're going to ask yourself, do you have the total, the final, the biggest, the everything? If you don't and you have the parts, then you're going to be combining those parts to get the total. And then there's different ways to combine the numbers. So you'd ask yourself, well, do I have equal groups or equal parts? If you don't, then we're just going to add those pieces together. You might have 2, you might have 3, you might have however many you have. But then it becomes an addition problem. We're just putting those numbers together. And then if you do have equal groups, hey, even better, because we're going to do repeat addition, also known as multiplying. Back at the top, let's say you do have the total, and you're missing a piece. You have one part, but there's some unknown there that you don't know. I guess if it's an unknown, you don't know it, then you're going to separate. You're going to separate the piece you have from the total. So you ask yourself, well, do I need equal groups? Do I have equal parts? If no, then you're just going to subtract. You take the piece that you have away from the total, and that'll give you the piece that's left over, also known as the difference. It's just a subtraction problem. If you do have equal groups or equal parts, hey, we're going to divide. That's repeat subtraction. And you'll see that a lot in problems that have fractions. You're dividing your total up into equal groups, and you have so many of those pieces. That's just working with fractions. It makes it really easy. You can even, oh my gosh, use those keywords or code words that your teacher made you memorize to make sure you're doing the right operation. So let's put this into practice with a real problem if you're still with me. We got Tina has 3 cats, Matt has 12 goldfish, Jerry has 2 dogs. How many pets do they have all together? Well, think about the who. Who's in this problem? Well, there's 3 people, Tina, Matt, and Jerry. I'm already thinking about what's going on here. How about the what? What's my number facts? What am I looking for? Well, we got pets. 3 cats, 12 goldfish, and 2 dogs. I'm going to start to draw my bars and think about, well, what's the big number? What's the total? What's everything? Do I have a sum? Well, they're asking me for that. They want to know what we have all together. Instead, my data facts are the parts, the pieces. Are they equal parts? No. I've got a group of pets. There's 3 cats, 12 goldfish, 2 dogs. There's different amounts to those things, so I'm going to just combine those together in the most simple way, which is addition. So I'm going to label all my bars. That's very important. I got pets up top. That's the total. Then I got goldfish, cats, and dogs. I fill in the numbers that I have for everything, and then I'm going to combine those just by adding them up, and it's 17. And then I like to... Your teacher likes you to do this. Write a complete sentence for the answer. Hey now. And so there it is, a very brief and yet somehow still long, how do us teachers always do that, introduction into the world of BAR models.